Sup masochists, so today we're going to be performing exploitation on iOS ARM64 and there's a use after free bug coded into this application. So we're going to perform some kind of heap overflow and exploit the bug. Okay, so anyway, if you've ever played RuneScape, you'll see that this is a tribute to RuneScape. Amazing game. Anyway, there's a few functionality that I've coded into this application. The first one is you can buy a legendary item. Yeah, but we broke out here. It's a hard life. We don't have enough money. So we're gonna have to figure that out. So we can also get a new quest. We can check out what available quests we've got. We can import items, and that just reads from an items.txt list and imports the items from there. We can leave our quests and we can leave the game. So let's get started. Just a quick note, I actually have two blogs that I wrote about this, and I'll leave the link in the description, but I go through how to reverse engineer and patch an iOS app for beginners, part 1, and I've also written a part 2 on that. So that actually will be assumed knowledge for this video, and I will write a corresponding part 3 for this video. I'm not going to kind of walk through everything in so much detail to the point that I may confuse people. I'm going to keep it pretty simple, but if you are interested in the more detailed explanation, then please check out the blog, and I will link it down below. Alright, let's take a look at the program. We're going to use Writeup and we're going to run it on Money Machine. So the first thing we're going to do is take a look at all the functions that are currently in existence within the program. There's 3 defined functions: buy items, list quests, and make it rain. If we run our program, you can kind of make a guess that maybe buy items is buy legendary items. So if we write 1, you can see it seems to do a check for how much gold you have and then make a decision around whether or not we have enough money. So why don't we take a look at this first function? So let me copy this in, and I'm just going to do S. Sorry, it's a little bit laggy. S, and then paste in that function and then type in PDF. And this will spit out the actual assembly output. We are not going to step through this line by line because otherwise we're going to be here for a very long time. But basically, all you need to have a look at is after the function prologue, there's a whole bunch of stuff like, there's a variable called money, which might be what is storing how much gold we have. And then there's this little thing where it's moving a particular number into a register, and then it's making a check about comparing this to money and then doing a jump into other areas of the program depending on how much money we have. Interesting. So you can kind of make a guess that if we have enough gold, we might be able to buy the legendary item, but if we don't, then we can't. And the number that we seem to be comparing happens here. Now, if you take a look at this, we can actually convert it into hex. So this would be F423F, and I've actually got that already here. So the legendary item, to our best guess, could be almost $1 million. Alright, so let's take a look at a different function. So why don't we have a look at make it rain? I wonder what this function does. So the same step, we're going to type in S and then the name of the function, and then write PDF. And then, let the computer chill out a bit, or my phone chill out a bit. It's been working overtime tonight. Okay, awesome. So basically, we've got this loaded up, and as you can see here, there's the function prologue. We are now working with the money variable again. And a bit lower down, you can see the same kind of thing, some kind of comparison going on. And once again, we've got the number F4240. So let's have a look at that. F4240. Convert. Okay, $1 million. And as you can see here, right under this, storing this particular number in the register, we have some kind of add operation. And money is actually, it's adding $1 million to money. So if you just take a look at the next few lines here. So basically, we can deduce that there's 2 functions. The buy items function, which is option number 1, which checks if we have enough money to buy a legendary item, which is roughly 999,000. 900, fuck, you know what I mean, that number. And and then the make it rain function, which is basically adding $1 million to the money variable. Okay, let's move on. Okay, so then if we just scroll back up to the top and have a look at the functions, we can see there's fopen fread, which, your guess is as good as mine. It is most likely some kind of file operation, which corresponds to import items. Then we can see sorry, not free, just free. And this is what you use to free a free and allocated thing on the heap. So we know that this would be used because there's a call to malloc, which is allocating something onto the heap. So our best guess is when we do new quest, let me type in 2, that is calling malloc and assigning us, some kind of a quest. And if we type in 5, leave quest, that clears it, and that's probably what is calling the free. However, to check if there's some kind of use after free, the vulnerability lies in the fact that there's some kind of code that is freed, but it's not nulled, and it's still being called and referenced by another function. So at this point, if we run available quests, this should not be able to read the quests that we've originally allocated because we freed it. But if we check right now, it still is reading from that area of the heap, which should not exist because that should have been nulled. So this is the actual vulnerability that we're going to work with. And we're going to turn this into, we're going to turn this vulnerability into something useful. We're going to call make it rain and see if we can buy a legendary item. So the whole goal here is to abuse this particular bug and use it to get rich and make money and make it rain, baby. So this is actually what the C code looks like. As you can see here, we've got the struct that contains the actual quest. We store the quest inside this char array, and we've got some kind of function pointer to list quests. List quest just basically has a static print statement, but the whole point, what we're basically trying to exploit is this section of code here, case 5. So when we click leave quest, it does not free the quest properly. All it does is it calls free new quest, but it does not null it. So when we are calling available quest is still referring to that section of memory on the heap, and that is why it still works. So time to exploit. Okay, so let's remotely connect to this running process on my iOS device from my Mac. So cool. All right, so now we are remotely attached onto the process running on my phone. And the first thing we're going to do is take a look at the main function. And what we're really wanting to do is we want to set a breakpoint at every call to malloc so we can dynamically pull the address where we're allocating to on the heap. So as you can see here, we've got a malloc right here after the call to buy items. So we're going to set a breakpoint right after that call to malloc. So there's our first one. And then you can see we're reading from a file called items.txt, and then we're calling malloc again. So we're going to set another breakpoint after the second malloc. And then if we keep scrolling, you can see there's fopen, so we're reading stuff from a file. Scroll down, then there's a call to free. So presumably this is freeing the initial malloc that we've done where we're allocating the quest onto the heap. So let's set a breakpoint after that. I'm going to do it a little bit further, maybe right here where the printf is. Doesn't really matter, you can do it straight after if you want. So let's do that really quick. I'm just going to speed through this, putting all 3 breakpoints. So first breakpoint, second breakpoint, and then breakpoint number 3. Okay, cool. So now what we want to do is we're going to go process continue, and then we are going to allocate a new quest. So as expected, we've hit our first breakpoint. So we're going to take a look at the register and pull the area where we've written to on the heap. So this is the actual heap address. Let's write that down. So heap. Okay, cool. So if we take a look at the heap, there should be like basically nothing there. As you can see, it's just like kind of empty. Okay, so we're going to go process continue. And now we want to basically free the heap. So we're going to go leave quest. And as you can see here, right after the free, we have hit a breakpoint. So let's take a look at the heap again. And as you can see here, we've freed it, but there's actual data written to the heap. You can see that it's different, completely different to what it was before we allocated the data onto the heap. So the data that we're expecting to see on the heap is actually Goblin Diplomacy, because that is the quest that we've been allocated, the quest that we've been given. I've actually prepared this a little bit earlier, but if you put in Goblin Diplomacy from text to hexadecimal, you'll see that in little endian, that is exactly the representation we see on the heap. So 47.6f, 47.6f, 62.6c, 62.6c. And so, that's goblin, gobble. And then here at the very end, we've got 60616379. 60616379. So this entire first section it's got the words Goblin Diplomacy written. And then down here is the actual function call to available quests, which I showed you earlier in the source code is written into the struct. So the goal is for us to read from a file called import items and hopefully malloc to the same area of the heap, and we want to basically overwrite the function call to available quests to the function make it rain so that we can be rich and then we can buy our legendary items. Okay, cool. So let's process continue. And what we want to do now is we want to call import items. But before we do that, we want to put into import items some ASCII characters so that we can fill it up and figure out where we want to basically write the function call. I have already done that. So what I did was I echoed A, so 41 is the hex representation of A, 42 is B, so A, B, C, D, E, F, and I've piped that into items.txt and then dropped that onto my mobile device. So let us call import items, number 4. And as expected, we have hit our second breakpoint, which is the second malloc that we set. So same thing, we're going to go register read and check if we've written to the same address. So as you can see here, this is a completely different address than the first one. The reason for that is I have not disabled any kind of security control. We are running on iOS 14, and so it may not write to the same section of the heap. So what we have to do when we come across an issue like this is something called heap grooming. We're going to have to keep spraying the heap with stuff until the only section of memory that is left in that zone to write to is that initial freed area that we freed for our quest. Obviously, this is a very simplistic explanation of the heap, but I hope that kind of gives you... I don't want to basically overcomplicate this video and freak people out. So basically, that's what we're going to do. We're going to keep spraying until we get the same region of the heap. So we're going to go process continue and type in number 4. We're going to go register read. Oh, straight away, we have hit the same section of memory. We are now at 40, 30, 40, 30. I'm just going to double check because I'm going to be honest with you, I'm effing tired. So, okay, give me a second. Okay, cool. It's the same area of the heap. All right, cool. So let's take a look at the heap now. As expected, we should have overwritten this section of the heap with A, B, C, D, stuff like that. If we take a look now at the heap, oh, sorry, we need to process continue before we take a look at it because it hasn't been written yet. We stopped it right after the malloc. So we're going to go process continue. We can see file read with the contents A, B, C, D, E, F. So now it's been written to the heap. So let's take a look at the heap. The process is running. So let's go process, interrupt, take a look at the heap. And as you can see here, there's 41, 42, 43, 44, 45, 46. Cool. So the actual area that we want to overwrite is the function pointer. So that is located right here, which is corresponding to 45. So ABCDE. So we want to overwrite E with the actual address of Make It Rain so that we can jump to Make It Rain and be a rich motherfucker. So Now we know what to do. Let's start the program all the way from the beginning and let's perform the actual exploitation. Okay, cool. So now let's get to the exploitation. We are going to connect back to my iOS device. Uh, Fingers crossed. This always makes me nervous. Okay, cool. So the first thing we're going to do, same thing, we need to put in those breakpoints at every single call to malloc so that we can see where we're allocating to on the heap. So we can check we are overriding the same heap. Okay, cool. So we are going to go BRSA and then put in the address. And then, okay, same thing, scroll up, find malloc, second malloc. This one's the actual file items. And we're going to paste that in. Great, so 2 breakpoints. And now we need to get the actual address, the runtime address of the make it rain function. So make it rain, this is the actual address of make it rain. And we need to basically turn this into the payload that we're going to put into items.txt. So I've got my little text editor here and I've got the address of make it rain. So as you remember from before, the place that we really want to edit is where the 45 starts, so where E starts, because that is where the actual function call exists inside the struct on the heap. So let me just kind of copy that and we'll work on it together. So this is the make it rain address. And we want to replace where it's at x45. So I'm just going to like put it on the next line to make it super clear. And because it's in little endian, we are going to have to put it in like this. So it is going to be BC 37 B4 04 01 and then 00 00 00. Okay, cool. Oh, fuck, I'm tired, so let me just check that this is the right address. Sick. Alright, cool. So let's create this file. We're going to paste it, and we're going to pipe it into items.txt, and then we're going to put it into var mobile, which is the directory that the application's running in. So we're going to put items.txt. Sick. Uploaded. Now we can continue with the execution. So we're going to go process continue, and we are going to go allocate me a new quest. And now we've hit our first breakpoint, which is at the first malloc as expected. So we're going to read the register and get the address that we've written to on the heap, and we're going to write that down again. So go heap with the address. So we've got 41C0. And then we're going to go process continue. Now we are going to leave this quest. So we're going to type in 5, quest is cleared. And now we are going to type in 4 for import items, and hopefully that should overwrite the same area of the heap. If not, we're going to keep spraying the heap until we are at the same heap region. So we're going to go import items. Now we're going to go register read and check the address on the heap. So the heap address we want is 41C0. We're at 7140. So we're going to keep continuing the process until we get the same area. Because I have the brain of a fish, I honestly just I just looked at the address and I forgot it straight away. Okay, so that is now the region of the heap that we've written. We are going to write items.txt to. And just to make sure we are writing to the same area, alright, sick. We are writing to the same area of the heap. Cool. So at this point, because we put the breakpoint right after malloc, it hasn't actually read it and put it onto the heap. So in order to do that, we need to go process continue. Now we have actually read the file contents onto the heap. So let's take a little look at the heap at this point. And it should be filled with A, B, C, D, and where E is should be the address of make it rain. So, okay, process is running, so we need to send in an interrupt, and then look at the... So if you can see here, we've got A, B, C, D, and then where it should be E is the address of make it rain, which is BC37B4 0, 4, and 1. Okay, so now because we've done it, hopefully this will now work. So we're going to go process continue, make sure it's running. And what we're going to do is we are going to call available quest. Available quest is now going to reach this same region of memory because, it's a use after free bug. And instead of jumping to, instead of like having some kind of error, it's going to actually read and jump to the make it rain function. So we're going to call 3 available quests. As you can see now, we are inside the make it rain function. And now if we run buy legendary item, you can see we are rich motherfuckers. And that's it. That's basically the entire exploit. That is the entire video, and I'm probably going to make more videos about other things. I'm not going to just be doing like offensive security stuff. I will actually be doing some blue team stuff, even though, it's not really sexy to show, but I'll do it anyway. So yeah, I hope you guys enjoyed it. And honestly, it's like so hard making YouTube videos because it's like really scary. Anyway, thank you.